Let's go back to the final analysis, which is the two-sample t-test or the independent samples test. So in this test, we are comparing two groups, and we'll use gender as our two groups to see if they differ on some interval or ratio variable. So there's many interval or ratio variables here. All of these are scale variables which are interval or ratio. Therefore, we can look at any of them. Let's look at let's conduct the analysis by going to Analyze, Compare Means and Proportions, and Independent Samples t-test. So when you click on that, you'll come up with the dialog box, and let's look at how to set this up. So there are two things you need to define here: the test variable, which are the dependent variables, which is the metric variable or the interval or ratio scales that you want to compare across the groups. And so let's pick some number of them and highlight them and move them to the right. So these are the variables that you're going to be calculating the means for and comparing across the two groups to see if the groups are different. Now the groups are going to be defined by gender, so we highlight gender, move it to the right, and we have to have one additional step, which is you have to define the groups, meaning you have to tell SPSS what value for sex is group 1 and what value for sex defines group 2. So 1 is male, 2 is female, so we're going to use the values 1 and 2 to define the two groups. So we know that group 1 is male, group 2 is female, and we need to specify that here in order to do the test. You don't need the effect sizes. In fact, you can just run the test as is without worrying about any of the options. And when you do that, you get this output table. The first table tells you the group statistics, meaning for each variable that you're testing, it calculates the sample size as well as the mean value of that variable for the two groups you're comparing. So for example, on the first variable, which is agreement with the statement, when national promises to do something, it does so. There are 139 males, 130 females. The male group has an average of 5.35. The female group also has an average of 5.35. And these are calculated separately for each group, and they happen to be identical, but they're actually different. They could be different for the two groups. For the next variable, you can see that the males have an average of 5.58, females 5.65. So you'll see as you go through this list, there are differences, or small differences for the most part in this example, between the two groups. But again, we don't need to look at this unless we have evidence that the null hypothesis of no difference between the groups is rejected. So in other words, we're going to be testing the hypothesis that there is no difference in the mean value for the two groups. And if that hypothesis is rejected, then we can come back to the means here and see which mean is bigger. So then we can interpret the data according to the means that we've estimated for each group. But let's first go to the table at the bottom, which gives you the results for the independent samples test. Now this is a little bit more complicated than it needs to be. In fact, that's because there are two different tests being conducted here. The main test, the t-test for equality of means, is shown, the results are shown in these last few columns. So it's on the right hand side. Starting with significance, the column that says significance, that's where you see the results for the t-test for equal means. The other test to the left of that is a separate test that is conducted by SPSS for equal variances. And SPSS conducts both tests at the same time. Now, the reason it does that is because in order to test for equal means, you have to make some assumption about whether the variances in these two groups are equal or not, because the formula for the test of equal means depends on what assumption you make. There are different formulas depending on whether you assume that males and females have equal variances, and it's different if you assume they have unequal variances. So SPSS very helpfully does a test for you to test for equal variances, and you can decide whether or not you want to assume equal or unequal variances based on the results of that test. So here, for example, the column that's labeled F is the value of the test statistic for the equal variance hypothesis on the first variable. In this case, when national promises to do something, if you test for equal variances, you'll get an F statistic of 1.825 and a significance value of 0.178, and so on. Now, this is all interesting, but it's not particularly useful because in many cases the results or the outcome for the t-test for equal means doesn't really change depending on what assumption you make. So in effect, you can ignore these two columns here and just focus on the significance value for the t-test of equal means. And so the column that you want to look at is the one that says two-sided p. So this is the p-value for the test of equal means, where, remember, the null hypothesis is that the means are equal, the alternative is that they are not, and if the p-value is less than alpha, then you reject the null hypothesis. Now again, we can choose what alpha we want. I'm going to use an alpha of 0.05. So for this column, I'm just going to go down this column and see if any of these p-values are less than 0.05. And in fact, you can see 0.997, 0.711, 539, 981. None of these are actually less than 0.05. The only one that comes close to it is the second last variable, which the variable is national has operating hours convenient to all its policyholders. And there appears to be a p-value of greater than 0.05 but less than 0.10. So it is what we call marginally significant. However, we'll ignore it for now because we are using an alpha of 0.05. So in effect, what this is telling you is that none of these variables have means that are significantly different between males and females. All these p-values are greater than 0.05. So we really don't have anything to interpret, because even though if you go back to the original table, the means of the groups in some cases look different. For example, there is in the third variable, the mean for males is 5.16, for females 5.29, and so on. Even though the means might look different, what SPSS is telling you is that statistically speaking, there is no difference between those groups. So in effect, the groups are the same or gave the same rating on these variables. However, if you did find a difference, then you would simply look at the actual mean and interpret that difference. So for example, we looked at this variable which says national has operating hours convenient to all its policyholders. We saw that that was marginally significant. It was significant at alpha 0.10, though not at 0.05. And you can see why. The difference between the means is a bit more than for the other variables. Males have a lower mean for this than females. If you remember, when you looked at the values for this variable, a higher number meant disagreement. So 1 was agree strongly, 7 was disagree strongly. So basically this is telling you that females are more likely to disagree that national has operating policies that are convenient because they gave a higher rating on this scale. So that's how you would interpret this data if you did find a difference between the groups. But again, in this case, the t-test has shown us that there is no difference between the groups using an alpha 0.05, so we can ignore that. And that's all there is to it. You can simply look at all these t-tests at one time. You can conduct all the t-tests at one time. You can look at all the results and figure out quickly what is interesting and what you need to talk about in your report.